Before I share myself and what's the main topic, I just give you a live demo. I guess it's always an interesting thing to make this event a little bit entertainment and educational, right? So this is what we do as a company called Timeplus. I'm one of the co-founder. So as you can see, this is the live price for the Bitcoin. I'm not sure whether you are mad for crazy for this stuff, but this is the real thing. If you check your Google, whatever, this is should be the same price. Even this should be more real time than what you see on the Google. And so essentially, we are building open source and also commercial version of stream processing to handle real time data. And we have all those nice dashboard. We have the SQL-based stuff. So that's why I'm very glad to join this meetup to talk about how we can potentially marry the data streaming with LLM, with vector database, with AI. So I go ahead, start the screen sharing. So no matter you love or hug, this is the key thing. And streaming LLM, I'm not sure whether that's a keyword you can search, but really want to see what's the potential over there. And I already go over the demo, so you know roughly about what Timeplus is. And I probably will write a blog about what I'm going to talk today, but I guess I can skip this one-on-one because the reason why you are here, because you are either expert or very passionate on this unstructured data and AI and vector or LLM. So I probably don't have to do this a one-on-one talk, but this is my understanding. Again, my domain is really on the data streaming or the real-time side, but my observation as more like a beginner or outsider, that is the trend of AI or the future of AI, at least is really about whether you can get bigger model. But sometimes people are talking about, can we get a smaller model, right? So whether it's LM or SLM, whatever. So it's really, people don't want to take this as a fixed thing. You want to get a much bigger model, have more context, or you can run the model very efficiently on your mobile phone, on your edge devices. So not just on the cloud, but also on the edge, on your smartphone, on your vehicle, on any other stuff. So edge will be very important. Also give you a lot of freedom to access any private data without sending your request or leverage other people's data. And the other thing is really about the real-time part. So again, I have a strong bias on this one, but I think if we can have a better future with the AI to understanding what's going on right now, they can give you a better suggestion, prediction. And one of the example, which is very commonly used in our data streaming space is this. Again, this is a chat app. So you want to understand like, hey, what's my status for my flight to New York? And the robot tell me, sorry, it was delayed for 2 hours. And you ask, can I arrive there, but without the delay too much? And what's the option and the cost? And if this AI is smart enough, they can tell you that is, yeah, you know what, that is, there's an alternative flight with maybe only one seat and only cost you like $1,500. But if you really want to take this chance, you will even have no delay, even sooner, arrive there sooner than expected. Then you make this, come to this hard choice, whether you should pay that extra money or just delay. But again, you see the value that is if the chat robot can access not just the pattern or the LM stuff, but also what's the current pricing, what's the policy, what's the flight status, what's the weather, inventory, your amount of points, all those stuff. So it can give you at least something you can really considering. So it's not generic, it's for you and only valid for the next maybe 5 minutes, even less. So this really will be not just a toy, it can help you to sell more tickets, it can help you to identify some risk, help you to earn some money by trading all those stuff. So that's the point. So I built a demo. Actually, I'm not really building it. I'm leveraging the nice demo from Oli, which is coming from our friend at Bytewax. So I'm going to share a little bit about how we can extend that demo to leverage Timeplus and also leverage the vector database. So again, let's show a demo first before I talk about the boring slides. Hopefully you are not too surprised for those logos, right? So HackerNews, this is Bytewax, Unstructured data, HuggingFace, Timeplus, and our organizer, Zilliz. So what I built is a system to load data from HackerNews via Bytewax. Then you can do a bunch of unstructured data things. Then again, let's try to see whether we can find any live feed we can talk about. How about, I'm not sure, maybe. Again, live demo, anything can go wrong. Anything can go wrong, will go wrong. See whether I can search anything dog food. Angry. People usually get angry on the Hacker News. Yeah, so again, this is more like a vector search to see anything you want to ask a question. It's not really answer machine, but try to see whether they match any comment in the database with some a ranking. But what I really want to show that is there should be some recent event. So again, I talked to every part briefly. So we get data from the HackerNews with their public API. Then this is via the Python code and using Bytewax as the framework. And the unstructured data is to, for example, like break the text into smaller texts and do some kind of cleanup, and using the HuggingFace to generate the embedding. We can talk about the code later. And the interesting that is the data is keep pushing to Zilliz Cloud via the Kafka Connect. Kafka is a system. So before I talk about that, I'm not sure how you guys familiar with Kafka, because I really want to really share something so that you can some takeaway. So raise your hand if you are okay for me to give you a 101 about Kafka. Okay, cool. So I'm not really wasting your time, which is good. So I skip this part first. Let's talk about Kafka. So you might be very familiar with vector database or LLM or AI. Everyone has its own domain. That's perfect, okay. But I'm coming from the data streaming space. So the reason why there's quite a lot of different players, including Timeplus and Bytewax and other, is it's much better time for us to work on this streaming processing, because it is more common for people to consolidate their real-time data in system like Kafka. And Kafka now is not just about Apache Kafka. It become a protocol just like HTTP, right? For example, no matter whether you are using Chrome browser, Safari, no matter your server is IIS, because it's in Microsoft building, or Apache, you don't really care what kind of browser it is. You don't really care what kind of server it is. As long as they are talking about this HTTP or HTML, it just works. So in the data streaming space, Apache Kafka is the original software, and they built this Kafka API, and now there's a many different Kafka API compatible vendors like Pulsar, like Rapanda, WarpStream, and there are different clients. It can be in different language. So essentially, Kafka have this this key value, and essentially the value can be anything. It's more like a byte array. It can be text for sure. That's very common, but you can even put a byte array, put some image, audio. It's perfect. Okay, it can be just anything, but usually people just put a JSON or arrow or put a buff, and this message is called is put into the Kafka, and as a client, you just talk to one of the server, which they call Bootstrap server, because naturally it is for distributed computing. So there can be a lot of servers, and you, as a client, you just talk to the first server, which is the Bootstrap. Bootstrap server helps you understand whether there's other servers in this cluster. And there's an idea about consumer and producer. Producer generate data and put into the Kafka cluster, and the consumer just consume it. But compared to stuff like MQ or message queue, I mean, Kafka is doing this in much more sophisticated way. That is, for example, in a message bus or message queue, you put the data there and you read one message, and other people cannot read it, and all those stuff. But in the case of Kafka, you can read a data multiple times, and the multiple clients can read the same data, and it is really designed for scalability. Before this AWS or Azure stuff, Kafka is designed for people to run this in the distributed way in your own local server, assuming anything can go wrong. And anything can go wrong will go wrong. So they have the idea of that about that is you can have multiple servers, and all the data is put into this logic idea about the topic, and the topic can have multiple partition. Partition is a bunch of files. So the idea that is you can put any data into it, you're making sure they will leverage multiple servers to save it. Each file is replicated to 2 or 3 times. So it is perfectly okay one server goes down because the data can be recovered from other servers. And you can add more topic, you can add any data into it without the limit of the local storage. So there's even idea about this partition and the consumer group. So imagine that is you have 3 servers, and you can, in the same time, you can have 3 workers to read the data from them, and each one can handle certain workload. So again, Kafka is a very sophisticated system, and now there's a lot of open source or cloud offerings. So it is very common for people to put almost anything into Kafka, no matter it's a log, a metrics, your transaction, your video feed, anything can be put into Kafka. You just put and forget. Then you can have other system like Timeplus or some other system to consume it. Kafka have an ecosystem. For example, we have a very nice, they call Kafka Connect, which is more like you can read the data from Kafka and send to someone else. So I found there's a very nice connector from the Milvus sync connector. So you can run Kafka and making sure that the data can be put into a different space. So for example, like this is my one of the Kafka clients. I can list my local Kafka. There's a topic called comments. And if I click the comment, you see there's a worker to move data from this topic to the Zilliz Cloud. And if I try to preview what this data was about, you can see that there's a data keep coming. And every data is a piece of a JSON, right? And the JSON is giving you what's the text, what's the embedding. So that's how, go back to the Zilliz Cloud, you can see the number of events. For example, this tab is to start the Kafka, right? So I have the Zookeeper, I have the Kafka server, I start a connector, and I'm also using the open source Timeplus core engine, which is called Proton, to start the server. And this Python script is to keep loading data from HackerNews and generate the embedding and send to the Timeplus database. And the Timeplus, you can directly forward this data to the vector database, but you might also want to do some filtering. For example, someone mentioned F word. You can easily using CQ to detect whether there's any sensitive word or F word. You can do those filtering, or you even only care about a certain topic. So you can easily using CQ to filter those data. Then you can send them to the vector database. There's a multiple component, and the key one is this Python script, and as you can see, that is the main entry is around work data flow for HackerNews, and we leverage Bytewax as a very nice framework for you to define multiple steps. So for example, you can define the HackerNews source, which is a very simple way to define, for example, like you can get what's the current ID for the HackerNews. Then you can see whether I want to get the recent 150 data, and you can try to figure out what's the HackerNews topic or story, then what is the comment behind it. Then you can download the link have the full context, and you can break those entire full text to multiple trunk, and you can generate embedding. For example, you can always using OpenAI, but if you don't want to pay the money to the OpenAI, then you can just leverage open source models such as HuggingFace, and it will generate this data like this. So essentially, you have a embedding, which is a very long float array, and you have the text. You cannot control the text on HackerNews, right? So that's something related, right? So it's not a failed demo, I hope. But again, it's a very easy for you to leverage all those open source tools without paying anything as a SaaS or API. You can just grab what's happening in the social media on your data center and generate the real-time embedding. You can leverage tools like Kafka and Timeplus to do some filtering or even do some kind of transformation. For example, you don't want your credit card or address directly as a text in your vector database. You can easily using SQL to turn those sensitive numbers to some master data. So and lastly, I want to mention that is the reason why we work on this open source project as well as the commercial product is, you may know Snowflake is very successful for sure, but such a OLAP or data warehouse is not designed for streaming or real time. So they are really focusing on how can get massive of data to generate some report or find some type pattern, but it's not really designed for streaming. And Kafka is a very good technology, and now it's become a new protocol for data streaming. However, it's really focusing on the storage side. You cannot really run SQL on top of it. There's some framework on that to run the computing, but it's not really the core problem Kafka to solve. Kafka is very good for as a message bus, as a buffer, as a storage, but it's not really for computing. And you might know framework like Flink, which is very powerful, very sophisticated, but it's not really a database. So they're focusing a lot on the computing side, but it is rely on Kafka as the storage, or they rely on the OLAP database as the running the ad hoc queries. So the way Timeplus is doing that is we try to provide a new framework of platform for you to easily process data in Kafka or in some REST API, and you don't really need a class of Java servers. You can just run this as simple as a single binary or as a Docker image. You can run the query, you can explore the data in Kafka or in other place. And we have some nice UI and data lineage in our commercial products. And some other stuff I want to mention quickly, that is you can run streaming processing using SQL without writing any Python or Java code. This is probably text will be too small, but the idea that is you can query what's going on in the live feed. Maybe I can just show the demo. That will be a little bit easier. So for example, if I go to yeah, so this is again the other example, that is you can get the real-time event from GitHub, right? When I run this select star from GitHub, this query never ends. It give you the latest data from GitHub, kind of like animation, but you get the idea that is who are creating new GitHub events, which project got a lot of star recently. So you can run such a simple SQL to explore data. Then you can do some filtering. For example, type equals maybe say watch events. Right, you can using SQL to easily filter certain data. Then you can run stuff like count. This one. And this will, from now on, keep counting how many events they observe. So actually, you can imagine that is such logic can be expressed using Python, using Java, using .NET, whatever. But SQL is such a common language, and we can just extend that language to help you to process the real-time data. And there's even more advanced stuff like what if the data is out of order, that is this event come first, but some event which should be come earlier but come late. For example, like you are getting some information from the car, and the car is just went through a tunnel. There's no Wi-Fi or 4G. Then the data arrive late. So all those are funny problem. We can easily express them using SQL. So it's a relatively new technology, but I think if you want to build your product for future, you should pay attention to this new trend. Leverage streaming SQL together with those real-time LLM and the vector database to help you build something, as I mentioned earlier, that is very meaningful, very smart, but also understanding what's going on. And there's a lot of use cases. In our case, you can do some trading analysis, figure out whether it's good time or bad time to buy or sell certain stuff. You can figure out whether you are being attacked by someone running a bunch of servers, which IP give you a lot of random requests. So even you can build some real-time machine learning. So the model can keep getting new data and keep training and tune those parameters. So you can have a better result to reflect the recent data trend. So I stop here, and if you have any question, let me know. I'm happy to answer maybe one question here, and then I can answer more questions maybe after all the sessions. Thank you very much. Yeah, so we work similar as Milvus or Zilliz. That is, we are database, right? So and you can run on your local Mac, on your cloud. So we are not really a data provider. We are happy to connect to any data. For example, for example, like this market data, right? So I have a bunch of data coming from different sources. In this one, for example, I get certain data from, this is CoinDesk, and this is or maybe Bitcoin. So they usually provide stuff like based on WebSockets. So we, as a database, we can easily consume data from WebSockets. Or if you're running your IoT or maybe a fleet, you can having those kind of sensor push data to us. Or you can load data from your database such as Postgres. So that's the technology called CDC. That is, any change you make on the database can generate a CDC message, and this message can be put into us. Then you don't really run your analytics workload on your mission critical database. I mean, all those stuff is running on us. We're more like a mirror, a real-time mirror, and you can understanding all the transaction stuff. So for example, what's the revenue for this hour without slow down your database. Again, yeah, we don't really sell data. We actually is a data tool for you to analyze the data. Yeah. Thanks so much. And happy to answer more questions. I'll be here for the rest of the day. So thanks so much.
Thank you very much for that talk, Jove.